Mechanics, Chapter 5, Statics. Mechanics is the study of how the object will respond or move when subjected to a force. In this chapter, we'll be focusing on statics. Statics means not moving. That means the object is stationary. Okay, let's take a look at the contents for this topic. Okay, I'll be doing in that order most of the time. I will start with forces, then we'll move on to free body diagram. I will be doing a resolving of forces. This apply to all vectors. Then I'll move to moments and finally equilibrium. Well, let's try to connect to what we have studied previously on motion. We learned that we use the kinematics to describe motion, and we describe motion in terms of its position, velocity, acceleration, as well as displacement with respect to time. Okay, but why is there motion? Or why is there no motion? Then we will have to study under different topics. So when there is no motion, we would like to know why. That will be covered in statics. And when there is motion, what causes the motion will be studied under dynamics. So what causes a change in motion? For example, when you talk about a book that is initially on the table. So when will the book move? How will the book move? What must be done to move the book? So what must be there to cause the book to change its motion? The answer is force. Okay, so this is what I've been talking. See over here, I have a book on the table. Okay, the book is not moving. So how do I actually make the book to start moving? I need to apply a force. So what are the forces acting on the book if it's not moving? Are there any forces? Answer is there is. In fact, there is the weight due to gravity, and then there is a contact force between the table and the book. But because these two forces are balanced, therefore the book is not moving. Okay, we'll be learning about that later on. So for the time being, let's see what is a force. We learned that a force is a push or a pull. A force is a vector, and that makes it very troublesome because we have to consider its direction. You will have to use vector addition here when you have more than one force. The SI unit for force is Newton. Types of forces. There are mainly two types of forces. All the forces that we encounter can be classified as contact force or action at a distance. So a contact force is one that is transmitted via physical contact. In this example that you can see, there are two groups of people playing tug of war. So the object here is the rope. They are pulling the rope. So they are in contact with the rope. And the contact force we are talking about will be the tension. Okay, let's take a look at another example. Here I have a ball. It looks like a lollipop that is moving through the air. So you can see that the air molecules are being displaced. So the lollipop is moving through the air in contact with the air molecules. As a result, there is friction. So friction is another example of contact force. Okay, next we take a look at the other type, which is non-contact or action at a distance. So this is transmitted without physical contact. In the animation that you can see here, okay, there is a magnet that is attracting this creature here, so that is hovering. So magnetic force is an example of non-contact force. On the other side, you see a ring. Okay, one big ring, another small ring. Okay, these two rings have light poles facing one another. That's why there is a repulsion force. And this smaller object can actually navigate above the bigger ring. Okay, the force present here is the magnetic force. Okay, probably you have come across the magnetic force that is used on the bullet train. Okay, they make use of magnetic force to actually navigate the train such that it can be moving at a high speed with a very small friction. Okay, next we are going to look at another type of non-contact force. Okay, this man is holding on to a charge rod. The charge rod actually repels the feathery light material. Another example, the comb which is charged attracts the paper. Okay, the girl here is touching two domes which are charged, so the hair actually get repelled. So the force we are looking at is the electric force. So electric force is another non-contact force. Next we look at free body diagram. Free body diagram is basically a diagram which involves forces acting on a body. So over here, as an example, I'm going to use this block of mass which is placed on the surface of the earth. So what will be the force experienced by this block? Okay, the force here will be the weight. So the weight will be experienced by the object. We call this object the receiver because it receives the pull by the earth. The earth here is called the actor because it acts a force on the mass. And how do we draw this force? This force will have to be drawn from the center of gravity, the CG of the mass down. Where the CG is the point where the weight of the object appears to add on. Okay, now we are going to practice finding the CG of different shapes before we move on to draw free body diagram. Okay, so for this cuboid, it's very simple. The CG will be right in the middle. Okay, if you draw two diagonal lines, okay, the point where the two diagonal lines cut will be where the CG is. Similarly, for this uniform bin, the point where the two diagonal lines cut will be the CG. Next, we go to this L-shaped object. This is slightly more complicated. What you can do is you can actually imagine when it is initially a square. Okay, the CG will be somewhere in the middle when the two diagonal lines cut. Then you cut away part of it, which is another square. So the CG now should be lower. Okay, so if you draw the diagonal line, the CG now should be lower down along the diagonal line. So could be somewhere around here. So the weight of the object will be acting from the CG. So that is one force that is acting on the object. So assuming that the object is suspending in the air, then the only force acting on the object will be the weight. So that will be the free body diagram for an object that is suspended in the air. As in, no other objects are acting on it or in contact with it. Okay, this is rather impossible. Okay, because the gravity will actually pull the object down, so it will come down and touch the ground eventually. So this scenario will be when the object is free falling and assuming there is no air resistance. Okay, now we are going to draw free body diagram for the ball, the rope, and the ceiling. So in this example here, we actually see three objects. We will start with the ball. So for the ball, let's start with the non-contact force. The non-contact force in this case will be the weight. So that will be the force that the earth acts on the ball. And the weight must be drawn from the CG downwards. Okay, next, the ball is in contact with the rope, so we have a contact force. This contact force must be where the rope is tied to the ball. Okay, so this is the point where the contact force will act. So this force is the force that the rope acts on the ball. I call it T. Okay, because the ball is not moving, that is to say that these two forces must be equal in magnitude. So when you draw the arrow, it is very important that the length of these two are the same. Next, we move on to the rope. Okay, here I'm going to assume that the rope is very light, so the weight is insignificant. So we are not going to draw in the weight of the rope, with the assumption that the weight of the rope is negligible. So what will be the forces acting on the rope? So again, if you look at the diagram, there will be two contact points. One is with the ball, the other is with the ceiling. So there should be two contact forces. So the first contact force will be the force that the ball adds on the rope. The second contact force will be the force ceiling adds on the rope. So this will be the free body diagram for the rope. Finally, we move on to the ceiling. For the ceiling is in contact with the rope. So the force acting on the ceiling will be that exerted by the rope on the ceiling. Okay, notice here that for the ceiling, there are actually other contact forces because the ceiling is in contact with the wall and the beams which actually support the ceiling and prevent it from coming down. But in this example here, we are not going to discuss about them. Okay, so we take a look at just the contact force between the rope and the ceiling. So with that, we are done with the free body diagrams for the three objects in example 2.2. Homework. Okay, you will go home and try the free body diagram for the cup. So we will stop here.